Alright, we are in chapter 3.4, which is proportional and non-proportional relationships, I believe. This is for IM1 or Integrated Math 1. I'm going to go through a few of the basic pieces we see on the screen here. So on the teacher preview, I do not see a due date, but you will see a due date. You will always see attempts next, and it's one of unlimited attempts. You will always have unlimited attempts. You can submit this assignment as many times as you would like until you get 100%. The next piece that we see here will be the number of questions. So this particular assignment has 4 questions. It's anywhere from 1 to 10 questions. We tried to cap it at 10. The next one is the grading policy. It's always best score, so your best attempt is the one you keep, and partial credits enabled, which means if you answer 1 of 4 questions, you get credit for the 1 question. Once you start your homework, you need to finish it before you can work on anything else. So that means if we click on the Start button here, on the bottom of your screen, this is the other piece you don't see on my screen, but on the bottom of your screen you will see Submit Assignment button down here in the bottom right corner. Whenever you are ready to leave the screen, you need to click that Submit Assignment button. Even if you've only done 1 question, you still click Submit Assignment. That way your teacher can see what you've been working on, how many you've worked on, what's your percentage. It calculates in the gradebook, and it won't lock you out of all of your other assignments because the system assumes if you don't click Submit Assignment that you want to come back to this one only until you have finished it, and we don't want it to do that to you. So just always click that button. On the right side here you will see 3 tools or 3 buttons. The first one is Explanation. It's telling us we're going to lose our attempt because it's going to explain this exact problem to us, not an example. This exact problem. So it's going to give you the solution and the answers. It's not going to then let you come type it in. You're going to get an X on this one and you have to try it on another attempt. The second one is Example. Just opens up this pop-up window so you can see an example of this problem type. Shows you exactly what it's expecting you to do here. Walks you through the problem and you can close it when you're done. And you can open this up for another example if you would like to see another one. Message Center is so that you can send your teacher a direct message with this problem attached. So we know exactly where you need help. Very nice feature. Alright, so for this one we have, for the high school basketball game, it costs $12 for every 3 tickets. And we can see that right there in the table. Cost is $12, number of tickets is 3. We want to complete the table by showing the cost and the number of tickets. So we can use a couple of different methods to do this. But what we want to do is first, let's write it out over here so that we can kind of organize it. For whatever reason, I can't write on that other board. So I'm completing this where I'm just showing you the blanks that we need to fill in. So what we want to do is we want to look at the relationship of X to Y. And if we think of the top column as X, the cost is X, and the number of tickets as Y, then we can compare these 2 values and say, okay, well, how do I get from one to the other? So if I'm looking at the 12 and I want to go to 3, I'm going down, definitely, 12 to 3, I'm going down, so I'm dividing by something. So if you're not sure what to divide 12 by to get 3, definitely go to the quick tables on this program and practice your times tables because that'll make this a lot easier process. But you can also do 12 divided by 3, and that would give you 4. So I can also say 12 divided by 4 gives me 3. And then, that has directly to do with these little triangles that we learned back in grammar school, where I can do a division. 12 divided by 4 gives me 3, 12 divided by 3 gives me 4, or I can multiply either one in the bottom either direction and I can come back to 12. So it's just that kind of little fact family. If you've never seen that before, it's definitely a very nice little visual to help you do that. So now we know that we're dividing by 4. That's the pattern here. Well, that's going down from top to bottom. So I want to go back up to the top. So instead of dividing, I'm going to do the opposite of division. I'm going to multiply. Because instead of going down, I'm going up. So 6 times 4 gives me 24. And then the next one I'm going down, so that goes back to division. So 28 divided by 4 gives me 7. The next number here, I'm going up from 9 to something, so I'm going to multiply by 4 again. 9 times 4 is going to get me 36. So I want to do that multiplication. And then the last piece, now that I've looked at all of these other pieces, we're going to do this last one, which is 40, and we're going down. So again, that's division. So we have 10. We're going to go ahead and fill the chart in here, and then I'm going to kind of take a step back. We're going to look at what does this actually mean when I'm dividing by 4 or multiplying by 4, because we always want to kind of take a thinking session. We don't want to just fill it in and say, okay, that worked. Why did it work? So if we look at x over y, or y over x in this case, because I'm kind of looking at the first column as x and the second column as y, if I reduce this, 3 over 12, I get 1 over 4, because they both divide by 3. And what I can do is I can look at this and say, okay, that means one ticket on the top, because that's the number of tickets are on the top, and this is the cost. It's $4, or you can just write cost there. So every ticket cost me $4. So that's why we're dividing the cost by 4 to see how many tickets were in there. Or if we have the number of tickets, we're multiplying by 4 to see what the total cost is. So just kind of this back and forth between multiplication and division. As long as we understand what we're doing, and it'll make a lot more sense. If we're just kind of blindly doing some multiplication and division, that doesn't necessarily help us understand any of this. So we want to understand that ratio so that we can keep moving forward on that guy. All right, so we're going to look at this next one here. We have a printer is printing photos. The table shows the number of photos printed in different amounts of time in minutes. Using X for the time and Y for the number of photos, do the following. We're going to plot the points, and then we're going to write an equation relating X to Y. So first, we want to plot these points, and they're showing us in this little table. We can see X is for time, and Y is for the number of photos, and that has to do with your X and Y axis. So make sure you're plotting these correctly, because that'll definitely change the answer if we don't plot them correctly. So for 1 minute, we got 3 photos. For 2 minutes, we have 6 photos. 3 minutes, we have 9 photos. And then 5 minutes, we get 15 photos. What I'm already noticing, I can see on my graph that this is very linear. We don't have the line tool on this one. They're not letting us connect them. But I can see that these are very, very linear. They look like they're in a line. So that's definitely a pattern that we want to look at. Now what we want to determine is what do we have to change X by? What do we have to multiply or divide by to get from X to Y? Or we could add or subtract something too. Sometimes that happens. So we're just looking at the pattern. How do we relate X to Y? So in this case, if we look at these numbers, and I want to go from 1 to 3, well, I'd multiply by 3, right? 1 times 3 will give me 3. So if I test that on this next one, 2 times 3 is 6. So that works. And then I can do the next one here, and we do get 9. And then the last one also works. We want to make sure that when we find a pattern, it works on all of them. So this, multiplied by 3, that is our constant of variation. And we're kind of taking a step back to direct, I'm forgetting my words, direct proportions, where we have y varies directly with x. Direct variations, sorry, not proportions. So our constant of variation, which is also our slope, or our change, is 3. So we can simply write it as y equals 3x. I have to multiply x by 3 to get y. It's another way to kind of think about it if that helps you say it that way. All right, we're going to go to our next problem here. All right, so with this one we have for each table determine whether it shows the x and y are proportional. If x and y are proportional, fill in the blank with a number in simplest form. So we're going to determine whether what we can see right now is proportional or non-proportional. So we need to do a comparison of x or y to x. And I keep doing y over x because that's rise over run. We really want to get in that habit of comparing y to x. So we have these pieces here, and we can even do it this way also, where we just look at the pattern. To go from 5 to 10, I'd have to multiply by 2. To go from 8 to 32, though, I wouldn't multiply by 2. I'd end up having to multiply by something bigger, so I'd have to multiply by 4. If I go back to 11, though, that goes 11 times 2 does get me 22, but it's not the same. That 4 throws us off, which means it's not proportional. So we want to make sure we click on the right one there. And you don't have to fill this in unless you click on proportional. So if you click on non-proportional or not proportional, then you don't have to do that. So we're going to look at the next table here. And for these pieces, we just want to see, is there some kind of proportional relationship? So 4 to 16, I do have to multiply. I'm going from a small number to a large number. So I'm going to multiply by 4. And then if we test this, we can do the same thing on the next one. 6 times 4 does get me 24, so that's good. 8 times 4 does get me 32, so this works. That is proportional. So I would click the proportional button, and then I would make sure that that's my constant of variation, meaning I have to multiply x by 4 every time to get y. So that's what we fill that piece in with. We're just looking at that. That's a direct relation to slope there. All right, last one we have. We're going to look at 2 graphs here. And on this guy, so we have each graph below shows a relationship between x and y. For each graph, determine whether x and y are proportional. If x and y are proportional, fill in the blanks with the number. So if we go back to direct variation just for a second, if we take a step back, just by looking at the graph, and you can do this on a table as well if it gives you enough coordinates to do this, but in order for it to be a direct relation or have a proportional relationship, we need to go through that origin, that 0, 0 point. So right away, from looking at these graphs, they're both linear, but I can tell that this first one is not proportional because it doesn't go through 0, 0. So I can immediately click not 0. I'm going to explain this mathematically in a minute. This other one goes through 0, 0 and is a straight line, so it is proportional. I know it is. Now we're going to take a step back and we're going to think about it, and I'm going to actually show you why. So if we look at the 2 coordinates here, that first coordinate, we have 2, 2. Oh, and instead I'm going to actually write it as a table the way we've been doing it. So there's 2, 2. And the second one is 3, 6. So we get 3 and we get 6. We want to see, okay, how do I get from 2 to 2? Well, I'd have to divide or multiply by 2. Nope, sorry, 1. I'm being silly. Okay, so with these ones, sorry, I jumped ahead a little bit there, but I should be multiplying these, not dividing them. I'm just losing my crazy mind here. So I grabbed 4 and 10. That was just another point on the graph just to test it. And it doesn't work. 4 times 2 does not get me 10. This is not proportional. So let's take a look at the second graph. In the first one, we have 0, 0. We don't really want to test the x and the y with 0, 0 because it's 2 zeros. That's not necessarily going to be helpful. We want to go to the next point. So we have 1 and we have 5. And then the next one, we have 2 and we have 10. Now we might even be able to hear a pattern there already, but we just want to test it real quick. So I have to multiply by 5 to go from 1 to 5. And if I multiply by 5 again here, 2 times 5 gives me 10. So that is a pattern. I have a constant variation of 5 there. So that's definitely proportional. And I have to multiply x by 5 each time to get to y. I can't test another point because it's not working, so or it's not on the graph there. I can't see it. All right, so that was section 6. I believe we're done with chapter 3, and I will see you in chapter 4.